Thank you everyone for coming. I'm Pascal from Germany, and I want to tell you today more about Sidekick, which is a CLI generator for your Flutter project and Dart project and multi-repo, whatever. I'm working for a startup called Wiredash, which is a user feedback tool. You can integrate in your app and get user feedback. It does an amazing animation, scales down your application. You can take screenshots, annotate your screenshots, and your users are very likely to send you more valuable feedback than without it. So please integrate in your application. I'm also working for Phantom, which is an agency, and we are like 15 Flutter developers, and I'm leading the team there. And we love automation. We automate a lot. We, for example, have a Telegram bot that opens our door in the office and things like that. And we love automation. We also automate our daily work. So, for example, getting packages for all our packages, getting the dependencies, downloading it. That's something we do like 10 times a day. So, of course, we automate this. We also bump our version regularly. So, for example, on the CI, like weekly, or sometimes if we release something, we want to do this. We do this in a way that we increment the version, but also do a very cool commit with a special message so we can easily find it in our logs. Updating localization files for our applications. Some translation people are working on the translations for our app. We, from time to time, before we do a release, pull them automatically into our app and ship the latest version of that. Like crazy things like release notes, but not as simple like checking the commits, but actually going to GitHub, checking the pull requests that have been merged, checking their descriptions, see if there are any Jira tickets, and pulling the information from there as well. So you can do crazy things when you think outside of the box. What about stand-ups? If you're working in a Scrum team and you have multiple repositories, why not show the last commits that have been merged in the last 24 hours or open pull requests, something that we have to discuss. Maybe some pull requests are open longer than a day, so we should talk about that. Things like that can be easily automated. And of course, publishing releases. We all know that. That's something where we usually start automating our stuff. So the big problem is, where do we actually place our code that does the automation? And that's a question I was working on this for a long time. And one of the solutions I came up with is, of course, writing bash scripts. And bash scripts are really cool because they work basically on any system. They even work on Windows if you know how to execute them. And they don't require any other tools to be installed. They just work usually. Of course, you can use other tools, then you have to install them. But usually, if you stick to the standard, it just executes. The problem with bash is that bash is hard to write and even harder to read. So if my coworker is writing a bash script, I have a hard time reading it. Writing got better with Copilot, but we also have to read it at some point. We also have no dependency management. So if you want to parse some JSON, you either have to hope that some other tool is installed on your system that's doing the JSON parsing, or there's simply no way to do this. Unfortunately, there's also no debugging, and we also cannot really test bash scripts. I did it once. It was a pain in the ass. It's basically not supported. So let's try to stay away from bash scripts. And because I have a background as Android developer, I know, yes, I can write Gradle scripts. They are fantastic. I even wrote some Gradle plugins, and I know that we can actually debug those plugins, and we can also write tests for those plugins. I did all of that. But in the end, if you write your Gradle script in your project, you're not going to debug it. To be honest, nobody does it. It's quite a pain in the ass. And instead, I also learned that it's a stable framework, and what I really love about Gradle is that it has this Gradle wrapper, and this Gradle wrapper automatically downloads the jar to execute Gradle, which is pretty cool because now you have a bash entry point, which requires no further installation, and you can execute Gradle. That's cool, but it's not so cool that you have to have Java installed on your system, which also means if you want to execute it on CI, you also need to have Java installed. Not great. Also, it feels a bit odd to write Gradle tasks to basically write a CLI program. It's just not right. It's not the right tool for the job. And additionally, because we are here in the Flutter track, Flutter and Dart are basically not supported by Gradle. So let's skip that. What about placing a Dart script in the tool repository. If you check the package layout of a Dart package, we have this tool package or this tool directory, and we can place Dart scripts there and simply execute them. Dart is great because it is easy to read and to write even for non-Dart or Flutter developers. We have dependency management, and we have a lot of packages out there that help us with automation. GitHub, for example, there are multiple Twitter packages out there. And because it's Dart, it's very easy to debug and to test. That's something that's built in, and the Flutter team, or especially the Dart team, is very, very keen to support that on every platform. The problem with Dart, with the tools directory and scripts there, is that we share the dependencies that we use in our scripts with our application that we use. So if you want to parse some file, some XML file, you suddenly ship that library as well in your real application, which could cause problem with other dependencies. We also have this problem that we have to have Dart installed on our system. Usually we do because we also execute Flutter and there's a Dart SDK embedded, but it's not exactly clear which Dart version is actually executing it. And you might run into problems like the one person, that script is working because they use a new Flutter version. The other person cannot execute it because they use an older Dart version. Okay, let's combine all of this into Sidekick and only take the things from the pro side. So first of all, what is Sidekick? Sidekick combines the best of all worlds. Everything I discovered over the last years that are good for automation are here. First of all, we have a bash entry. And the bash entry can be executed. It automatically downloads everything. It also does auto-compile. So if you do a change to your script and you execute it again, it will automatically compile, detect that change, and execute it itself again. It is automatically downloading a Dart runtime, which is very cool because now when you write a GitHub action, you can just execute that script and it automatically downloads Dart and executes your Dart code, whereas otherwise you would have to install Dart on the system, which you might not even need for the simple automations you do. We use Dart because it's quite easy to write and read, and it's also extensible with the dependencies from pub. And we already talked about this. Of course, debugging and testing is supported even with Sidekick CLIs. So this is Sidekick. It is hosted on GitHub under the Phantom XYZ organization. And yeah, it's a CLI generator. So Sidekick, the CLI Sidekick generates a CLI for your project. And I can only repeat what we integrated. So it's a self-executing. The generated CLI is then self-executing. And we ship with built-in commands for your Flutter and Dart project. So there's a Dart command and a Flutter command. You can write your own commands as well. And this is new. You can share your commands with the community and install commands from other people. So how do you create a new Sidekick CLI? You call Sidekick init. And yes, you have to have Dart installed on your system, but only the person that generates it at first. Once you call that, we ask you for a name for your CLI. We prefer short names. That's why we have a package included that's called acronym. It finds an acronym based on your project path, and usually it matches quite well. So take whatever you want. In this case, I haven't found something good. I take VGS for this example today. And the next thing the CLI asks me if I want to install the Flutter wrapper, which is a tool that helps you to pin the exact Flutter version in your project. Just make sure that the CI and your coworkers are all using the same version. And this is supported by the Sidekick CLI that you can use a pinned version. If you don't want it, you can use the version on your system, but you are getting non-deterministic builds. That's usually bad. Once you confirmed everything, the CLI is downloading the embedded Dart SDK to execute your Dart script. And if you execute it for the first time, you will see the following commands. So this is all generated and immediately executable. We have the commands in alphabetically order here. It's like you can analyze your project, you can clean your project, you can You can have your Dart command, so you can call VGS Dart, and then you're sure you're always using the Dart version that is basically embedded for the project. And the same for the Flutter command. Our deps command is our most used one, which loads the dependencies for all the packages in your monorepo. And the sidekick command, come later to that, it manages the sidekick CLI, basically. This is the code that we actually generate. I want to quickly show you what's inside. We have our bash entry point, and it uses the magic bash scripts in the tools directory. This makes sure that the Flutter is downloaded, that the environment variables are correctly set, and that the paths are correctly resolved. And you can use the CLI basically from every directory on your system. The main Dart file is called from the sidekick CLI, but it actually just forwards to the command registrations, where you register all your commands, and the commands are placed here in the commands folder. Let's look into the command registration, because this is where basically all the magic happens. It's a main file basically for your CLI. First, of course, you have to initialize sidekick. There you may have to provide some paths, and then you add new commands to the runner. These are all the pre-installed commands, and later we will add a new command. These are the Flutter and Dart commands, and they basically look for the Flutter SDK path, which can provide here on top by default from the system, but it could also be from the Flutter wrapper, which saves it into the .flutter folder in the root of your repository. Those paths are relative to the root of your repository, but that can be changed. It's Dart code, you can change it however you want. Let's write a new command. That's something I want to show you today, that you can extend your CLI and create your own automations. And of course, we want to build our app for web, for example. The reason why I chose web is because in this command, you usually put in quite a lot of arguments, and you want to share this with your team. You not only want to have this in your GitHub action, but you also want to be able to execute this on your machine with all the commands. You don't want to forget anything. We have a name and a description for the command, and the run method will be executed. Here it calls the Flutter SDK and builds the project in the VGS project root. That's all, and we can directly execute it. We don't have to manually call any compilation. First of all, we have to register the command. Don't forget that, otherwise it will not be detected. But then we can execute it. It takes like 5 seconds until the CLI is compiled, and afterwards you can execute it and see that it's now registered as a new command. We can execute that command, and it does what it should. It compiles our application for web with the arguments and says the part where it's saved in the end. Of course, you want to share this command eventually with others from the Flutter community. I heard crazy stories about people that want to share commands in the future. That's why we spent the last 2 months basically to get the plugin system ready, and I'm happy to announce that it's now shipped and you can use it. There are no plugins out there besides from us, but I'm very happy if people are actually building plugins, because it's really cool how the system works. What you call is, you call your CLI sidekick plugin install and place there the package name from pub, basically. What we then do is we download your pub package, which is published on pub. You can also give us a local path for testing, of course. We download the dependencies using our embedded Dart SDK, and then we execute the install.dart file in your tool directory of your plugin. From there, you can do basically anything. We pass you the paths for the sidekick CLI where you want to install your stuff, and then you're basically on your own. Of course, we support you with some helper functions, and let's look how it actually works. This is the UI, so we download the installer, we execute the installer, and then the installer is executing whatever it wants to install. We have different templates. We start here on the right, and on the left, it's hard. If you want to share some code on pub, you should go the yes path, but we start with the no path. What if you don't want to share code on pub with the people that install your plugin? Basically, you dump all the code that your plugin is generating into the CLI of that user. And it looks like this. We call the sidekick plugin create function and create this template. And yeah, the only thing we generate is the install.dart. And of course, it has to be a package, so we also generate a pubspec YAML and some other files. But important is the install.dart file, and it looks like this. First of all, at the top, you get the package, and then you can write some files. So for example, here I write one file. We, in a minute, look into the contents there. And at the bottom, we use that to register it. Plugin registration was very fun to implement because we are actually using the Dart analyzer to analyze the sidekick tool that's installed on your system. We find the exact line where we want to register your command, and we insert the code there. The install only sidekick plugin command, very good name, is placed in that file that we write on the top, and it looks like this. This are the only files that are installed, so we write that file, and at the bottom we register that line. It was done with the analyzer, and it was a lot of fun to actually use the analyzer to do that. Definitely check out the code. We have two others, but I'm running out of time, so basically you can also share your whole commands. It looks like this, but if you want to share your whole commands, you also have to add a pub dependency. You can do this with our other helper functions. You can add a pub dependency, or you can add a local dependency. And depending on if you're using it locally, if you have a local repository where this is stored, you can use it either way. The other one is that you want to have shared code. This means that you have some shared code in a package, so you add it as dependency, but the generated command only uses that code. Not the command is shared, but the command uses some of the shared code, which is super convenient because users of your plugin might then be able to manually adjust whatever they actually need, adjust some names, add some new arguments. So it's basically their code, but they're using some parts of your library. It's really convenient to get started. The plugins are shared on pub.dev. You can search by plugins that are using the sidekick plugin installer dependency. Right now, there's only sidekick Vault inside, but we just published it this week. Probably we will have many, many more next week when the community is contributing their own plugins. Please check out our repository and install your first sidekick CLI and share them with me and with the community. Thank you very much.